Formally put, an equation is a statement that sets two algebraic expressions equal in value. Let me try and explain this in a more informal way. Let's say I think of a number and my number is in this box. I'll tell you the answer if another number is added to, or subtracted from, or multiplies with, or divides my number. Then would you be able to tell what my number was? For example, if I said my number plus 6 is equal to 15. That's another way of saying 6 more than my number is 15. Therefore, my number, which is contained in this box, must be equal to 6 less than 15, or 15 minus 6, which is 9, right? 9 plus 6 is 15. Similarly, if I said my number minus 10 is equal to 28, another way of saying that is 10 less than my number is 28. So what's my number? My number in this case obviously is going to be equal to 10 more than 28, right? Which is 38. And you can check that 38 in this box minus 10 is equal to 28. What about multiplication? Let's say my number times 4 is equal to 24. That means 4 times my number is 24. In order to find my number, you are right, you would need to divide 24 with 4. And that would give you 6. And 6 times 4 indeed is equal to 24. Similarly, if I were to say my number divided with 3 is equal to 9. So there's a big number and you cut it down into 3 equal pieces and each piece is 9. Therefore, the big number must be 9 times 3, which is 27. And indeed, 27 divided by 3 is equal to 9. Like I said, every equation has two expressions, one to the left and one to the right of the equal sign. As the expressions are initially equal, if you apply the same maths operation on both sides, the new expressions that you get are also equal. We take advantage of this basic fact to solve equations using the method of balancing. If you look at the first equation, something plus 6 is equal to 15. We don't need the plus 6. We only need this something, this number. Therefore, we need a 0 here, and to get a 0, we subtract 6. Plus 6 minus 6 will give you 0. So you have something plus 0, which is the same as that number something. Adding or subtracting 0 doesn't make any difference. But if you do that, you need to subtract 6 from the other side of the equation as well. And therefore, we have this number as equal to 15 minus 6, which is 9. In the same way, in this equation, the number minus 10 is equal to 28. We don't need the minus 10. We want to get a 0 out here so that we only have the number on the left hand side of the equal sign. So we add 10. And if we do this, we need to make sure we add 10 to the other side as well. And therefore, the number minus 10 plus 10, which is the number plus 0 or minus 0, is equal to 28 plus 10, which is 38, right? And similarly on this one, the number times 4 is 24. We don't need the times 4. Now how do we get the number times 1? Remember, a number times 1 is the number itself. So we don't need a 0 over here now. We need a 1. Therefore, we divide this with 4. So we have 4 divided by 4, which is 1. The number times 1 is the number itself. But if we do that, we need to do the same thing on the other side. So the number becomes equal to 24 divided by 4, which is 6. And similarly on this one, the number divided by 3 is equal to 9. We don't need this division. We just need the number. So we want to say the number divided by 1 or times 1. Therefore, we multiply this with 3. A number divided with 3 multiplied with 3 will give you the same number. And if we do that again, we should be doing that on the other side of the equation as well, called the right hand side. Therefore, the number is 9 times 3, which is 27. So these equations could have been solved by inspection, like I showed you first. As these are easy equations to solve, you could just guess the answer or use some logical reasoning, but then balancing is the formal way to go. In more complicated equations, we use the method of balancing, that is, adding, subtracting, multiplying, or dividing both sides of the equation with the same number. In an equation, the unknown, or the number that we need to find out, is often represented by a letter of the English alphabet, like X, Y, Z, P, Q, R, and so on. So this equation could be written as X plus 6 is equal to 15. This could be written as, let's say, Y minus 10 is equal to 28. This one could be written as P times 4. Now P times 4 in algebra is written as 4P. That's the same as 4 times P is equal to 24. Or this one could be written as A divided by 3 or A over 3 as a fraction is equal to 9. Let's try out a few examples. Let's say we have 5x minus 6 is equal to 29. Obviously, x is the unknown, or x is the number that we need to find out. Now 5 times a number minus 6 is equal to 29. Now before you go on to find out what's x, you need to find out what's 5x. Now you should tell yourself, the moment I know what's 5x, 5 times a number is something. Let's say you know what's 5x. So you could easily divide that answer with 5 to get x, right? So at this point, you want to focus on finding 5x, not x. And to do that, you obviously want to get rid of this minus 6 by adding 6 to both sides. So we have 5x minus 6 plus 6, which is 0, or 5x is equal to 29 plus 6. And that's 35. And x is nothing but 5x divided with or over 5. And you do the same thing on the other side. 35 divided with 5 or 35 over 5, which gives you x is equal to 7. Now a quick check. If x were to be 7, you would have 5 times 7, that's 35, minus 6, that's equal to 29. So that works. That value of x will make the left hand side of the original equation equal to the right hand side. Therefore, this answer is correct. Let's say you made a mistake somewhere and you didn't get x is equal to 7. So 5 times another number minus 6 will never going to give you 29, right? So you would immediately get to know, hey, I got the wrong answer. I must have made a mistake somewhere in my steps. Let me check. Here's another one. Let's say there's a number called t. You divide that with 3. You add 2 to the result, and that gives you 17. The question is, what's t? Can we solve for t? Finding t is also called solving for t in this equation. So let's get going. Just as in the previous example, our focus should be initially on t over 3. We should try and find out what t over 3 is before we went on to find out what t is. And therefore, we're going to subtract 2 from both sides. That would give us t over 3 plus 2 minus 2 is plus 0, or t over 3 simply is equal to 17 minus 2, which is 15. Now what this means is a number divided with 3 is 15. To find the number, multiply this side with 3. The 3 and the 3 will get cancelled. So you are left with t times 1, which is the same as t. But if you do that on the left hand side, you should be doing that on the right hand side as well. Therefore, you have t is equal to 15 times 3, which is 45. Again, a quick check. 45 over 3 is 15, plus 2 is 17. So that works. Here's another one. 4 minus 3p is equal to 6, let's say. Obviously, we want to find out what p is. So our first focus is on 3p. We want to find out what 3p is and then go on to divide that with 3 to find out what p is. And to be able to do that, our first job is to get rid of this 4. So you subtract 4 from both sides. 4 minus 4 is 0. Minus 3p is equal to 6 minus 4, which is 2. Now at this point, you want to tell yourself minus 3 or negative 3 times a number is equal to 2. I need this number. I don't need negative 3p, I just need p. Therefore, I'm simply going to divide both sides of my equation with negative 3. Because if I do that, the negative 3 on the top cancels with the negative 3 on the bottom, and you have a 1 here, and 1p is the same as p. Therefore, you get p is equal to 2 over negative 3, or positive 2 over negative 3, a positive over a negative is a negative, so this is negative 2/3. How about this? Let's say we have 7y, or 7 times y, where y is the unknown, minus 12 is equal to 3 plus 4y. So we have a y on the left hand side of the equation as well as on the right hand side of the equation. Remember, we need something y is equal to a number on the other side. So we need all the y's on one side of the equation, preferably on the left. That's by convention. So we could start by subtracting 4y from both sides. Now what that will do is, it will nullify or cancel the plus 4y on the right hand side, so you have a 0 here. And if you do that, don't forget to do the same thing on the other side. Therefore, we have 7y minus 4y, which is 3y, minus 12 is equal to 3 plus 4y minus 4y is 0. 3 plus 0 or 3 minus 0 doesn't matter. It's just 3. Now, you just have a y on the left hand side of the equation. There's no y on the other side. The other side is a constant number, 3. So our next job is to get rid of this minus 12 by, you're right, adding 12 to both sides. So we have 3y minus 12 plus 12 is nothing but 0. They cancel, is equal to 3 plus 12, which is 15. So 3 times y is 15. To find y, you divide both sides with 3. The 3 and the 3 will cancel. You have a 1 there. 1y is the same as y. So we have y is equal to 15 over 3, or 15 divided by 3, which is 5. Let's try a slightly different form now. Let's say we have 5 parentheses x plus 4, which essentially means 5 times the sum of x and 4, minus 8 times 4 minus x is equal to, on the other side, let's have 25, minus 3 parentheses 7 minus x, or 3 times 7 minus x, plus 144. We have 3 parentheses, 2 on the left, 1 on the right, and our first job is to apply the distributive property and open up the parentheses. 5 multiplied with x plus 4 is the same as 5 times x. That is, you want to multiply the number outside with each term inside the parentheses. So this is 5 times x, that's 5x, plus 5 times 4, that's 20, minus 8 times 4, that's negative 32, and negative 8 times negative x is plus 8x. On the other side, we have 25, minus 3 times 7, that's negative 21, and negative 3 times negative x is plus 3x. plus 144. Let's combine the like terms. We have a 5x, we have a 8x. So 5x plus 8x is 13x. Plus 20 minus 32 is minus 12. Is equal to, we have only one single term in x on the right hand side. So that's 3x. And then we have 25 minus 21, that's 4. Plus 144, that's 148. We have x on both sides of the equation at this point. We need all the x on one side and all the constants on the other side. Let's do them one at a time. So to get rid of this 3x, you want to subtract 3x from this side. So that 3x minus 3x is 0. And if you do it, remember, we need to balance the equation. That means do the same thing on the other side. So that we have 13x minus 3x, that's 10x, minus 12, is equal to 3x minus 3x obviously is equal to 0, plus 148. 0 plus 148 obviously is equal to 148. Our next job is to get rid of the 12 on this side. You only want to have a term in x. You should add 12 to this side so that minus 12 plus 12 will give you 0. And then do the same on the other side. Which means 10x plus 0 or simply 10x is equal to 160. To find x, you know what to do. Divide both sides with 10. Thus, x is equal to 160 divided by 10 is 16. So this is how you solve linear equations in a single unknown using the method of balancing. Single unknown means there's only one unknown, x. We don't have an x and a y, or an x and a y or a z, right? We only have x. So that's a single unknown in the equation. And then a linear equation will have the highest power of the unknown as 1. So if you look at the terms in x, they all have x or x raised to the first power. That's what you call a linear equation. Hope that helps. I'll see you in another video.